Our next presenter is Rosa Yuliana from Universidad Nacional de Agustin de Arequipa.
Hello, my name is Rosa, and this in progress research was done with Olenka Vargas and Roberto Rodriguez. Olenka and me, we are recent graduates. We are Peruvian too. Our work focuses on visualization for sleep electroencephalograms. What is the motivation for this work? Clinical data is mainly composed of multivariate time series, and this leads to a complexity in its analysis. Also, we need to focus on a good way to visualize this data. In this diagram, we see how we perceive the information that is around us. For example, the fastest side is compared to the velocity of a computer network. Then is touch that performs as a USB key. Then is hearing and smell that performs as a hard disk, and then taste that is compared to a calculator, and that tiny square at the corner is the information that we perceive consciously. This demonstrates that information that we perceive with sight is a lot, and we receive it in less than a second. Sleep is information for sleep. When we sleep, we have two phases. First, REM phase and non-REM phase. REM phase is when we have an active brain in a paralyzed body, and non-REM is when our brain is quiet. Non-REM is divided into 4 stages, as we can see in the second figure. Each stage is explained by the number of waves that we can see in each one. But how do doctors make a diagnosis of sleep? And doctors, what they do is analyze each sheet of registers. But this is so difficult because, as we can see in the second figure, this is just a record for 5 seconds, and they had to make a counting in each wave that there is, and this is a lot of data. And of course, there are a lot of works that make this classification automatically. For example, here we have a sleep software that is made on Python, and this work shows the source data, an histogram, a spectrogram, and also the parts of the brain that are activated in each signal. And also this work presents settings that we can change the frequency for each signal. There is another work that shows this classification, but focuses just on wake, REM, and non-REM phases, not on each one from non-REM stages. This is another that uses deep learning methods for multivariate time series, but the visualization they got is not so efficient. So what we want to do is to get a better visualization for sleep electroencephalograms, where we can have a pattern for patients that are healthy and patients with sleep problems. Similarity measures for multivariate time series, and the most common is dynamic time warping that tries to align the path in the time series. And the one we use is EROS, that comes from the extended from minus norm, and uses singular value decomposition and principal component analysis. Then for reduction dimensionality, we have the project on the first, that is principal component analysis, that is the most common, and the T-distributed stochastic neighbor embedding. The last one is the one we use, and this is more suitable for when we had more variables. So what we do is we extract segments of 30 seconds from the data, and we store it in matrices. Then we calculate the similarity measures. This is done with dynamic time warping and errors. And then we project it in a low dimension. For this, we use the TSNE. And the experiments and results. And the data set we use is sleep recordings and immunograms from FissioNet. This is in European data format. This contains 70 healthy patients and 23 patients with sleep problems. The age range is between 20 to 66 years old. And from the 7 signals that they provide, we use the first 4 to 100 hertz. That is 100 records per second. And the result we obtain is better with errors, because when we use the dynamic time warping as a similarity measure, it takes around 13 hours, but with the errors is less than a second. And this is an image from electroencephalograms, and the image from the back, it shows 30 seconds, and in front we have just 1 second. This is our results for healthy patients. On the left, we can see the visualization we get when we use dynamic time warping, and the right is the visualization we get for when we use errors as a similarity measure. Both shows that we can have a clustering for stages, and the bar in the right shows the time for the data. Here is from 1 hour to 13 hours. Then patients with sleep problems. As we can see here, when we use dynamic time warping, we cannot see a pattern and all the points that represent 30 seconds of sleep don't show anything. But when we use zeros, we can see a pattern that is elliptical. When we make more experiments, we can see that is a pattern that is common with most of the patients that the data provide us, as we can see here. As future works, we want to make an interactive visualizations when we can choose each of these points and see their temporal location in the electroencephalogram and make a linear correlation diagram. We are using this approach that was presented before by Nguyen Minh, who used EROS and TSNE as a visualization. If you want more details and further information, on my poster I have a QR code where you can scan and see each diagram in more detail. Thank you.